Welcome back to another one of my applications of differentiation videos in my series that will be focusing on finding critical points. And this will be the second episode in finding critical points. Okay? Make that up here. Number 2. So, basically, I have some pieces of paper that explain my critical points, and hopefully you've watched the previous video, the number 1. But basically, if you haven't, a quick run over is that to find critical points, there's 2 steps. You got to find critical numbers, and then you sub them in and find critical points. And what do you mean sub in? Well, critical numbers, you basically find the derivative of a function, set it to 0, or set it to not exist or undefined, and then you will find your critical number. And then once you have your critical number, you sub that back in into the original function, and if it comes out defined, then it's a critical point. If it doesn't come out defined, it means it doesn't exist within the domain, therefore it's not a critical point. It may be a critical number, but it's not a critical point. Anyway, little quick overview again. If you guys don't understand what defined and defined and undefined and exists and doesn't exist, when you only really do the doesn't exist non-defined stuff when you're working with fractions. So if you have a function over a function, and when you focus on the top, that's when you have it equal to 0. But when you focus on the bottom, you set it to undefined or doesn't exist. So in terms of fractions, when something doesn't exist or is undefined, it means that you have a number on the top or something of nothing, and you can't have something of nothing. When something is defined or does exist, that means you can potentially have nothing of something, because you can always have nothing of something, but you can't always have something of nothing. Anyway, I explained those in my first video, so I'm just brushing over them. But let's just get stuck into our first and only example, which will be x take 1 over x squared plus 4. So we have u over v, we have a function over a function, therefore the derivative will be u dash v minus u v dash all over v squared. Okay, so the derivative of x take 1 is just 1, and then we multiply that to v. V is x squared plus 4, and then we subtract u, which is x minus 1, and then we multiply that by the derivative of v. The derivative of x squared plus 4 is just 2x. And that'll all be over. V is x squared plus 4 squared. Okay, so I've already done the expanding out and taken away, and basically you're left with negative x squared plus 2x plus 4 on the top, and the bottom, we want the bottom to stay the same. Okay, and that is the derivative. Now, when we're focusing on finding the critical numbers on the top, what we do is we set the derivative to equal 0, and that means we set the top only equal to 0, which may confuse some of you. We'll talk about the bottom after we finish solving this, but for now we're solving the top. So we have negative x squared plus 2x plus 4. We can use the I forgot the bloody rule now. It should sound familiar, but it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. For the life of me, I can't remember what it was called. I have it on the tip of my tongue. But anyway, so we're going to find the x values. So we're going to sub in negative 2, because, well, b is 2 and it's negative b, so it's negative 2, plus or minus the square root, b squared, 2 squared, minus 4ac, which means 4 multiplied by negative 1 multiplied by c, which is 4. All over 2 multiplied by negative 1. Okay. Now, that means we have negative 2 plus or minus the square root of 20 all over negative 2. Okay. That's the way I was taught to do this. X equals negative 2 plus square root of 20 on negative 2, and or x equals negative 2 minus the square root of 20 on negative 2. So now we're looking for our two x values. X could be this or it could be this, and we're going to find both of them. So here, what I'm going to do is I'm going to put a negative 2 on either side. I'm going to give a negative 2 as the denominator for this and for this. So it's going to be negative 2 on negative 2 plus 20 on negative 2. And on this side, it's going to be x equals negative 2 on negative 2 plus negative 20, the square root of 20 on negative 2. Now, if you're familiar with surds, you should be able to do this pretty alright. But basically, this equals, that's 1 plus, if you use surds to solve this, you get this root 5. Okay? But you have a negative because of the bottom. The bottom of the fraction makes it the whole thing a negative. And on this side, you have x equals, you have 1 here, 1 plus, because these two will cancel each other out, and we'll just have square root of 20 on 2. If you use surds, just like here, you end up with square root of 5. And these are our two x values for the top half. Okay? Now we do the bottom half. How do we do that? Well, stay tuned. So we set the derivative equal, or we set, not equal, we set it to doesn't exist, undefined. Okay? And what that does is basically set the bottom to 0, because when the bottom is 0, like I explained earlier, it's undefined. So the bottom was x squared plus 4 squared. How do we solve this? Well, this is the easy bit. Just like before. But we've got to get rid of the squared first. So we square root both sides. And what that does is it cancels out the square root. Square root of 0 is just 0. The square root of something squared is that something. So now we're just left with x squared plus 4. Now, we can use that other rule that I keep forgetting, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, hopefully you're familiar with this and you can see this, but if you can't, basically x squared is the a part. Well, the 1 in front of it would be the a part, and this 4 would be the c part. And because, think of it as x squared plus 0x plus 4. That's the exact same thing. But you don't write 0 times x, you just leave it out. So the b will be 0, so negative 0 is just 0, plus or minus 0 minus 4, a, which we said was 1, and c, which we said was 4, all over 2 times a, which is just 1. And this is what we're left with. And just like before, we're going to have to solve it as such. So x equals we're going to do the positive one now, so it's just going to be plus, or you don't have to write the plus, but you can, so it's going to be negative 16 on 2. And the other one, you write your or, x equals negative square root negative 16 on 2. Now you're sort of thinking, well, hopefully you're thinking, unless you know how to do it, you can't square root a negative. So, use imaginary numbers. And I don't expect you to notice if you don't know imaginary numbers, but basically, I equals the square root of negative 1. That's all you really need to know for this. So, we can split this up. The square root of 16 multiplied by the square root of negative 1. That's the exact same thing. If you multiply these together, you get that. All over 2. And this x value will be negative square root of 16 multiplied by the square root of negative 1. And hopefully, in the, you may say, well, you may say I'm just jumbling words, but this negative at the front, that doesn't affect this. It's just when the negative's inside the square root, okay? Then when it becomes a problem. So here we have x equals the square root of 16 is 4. 4 divided by 2 is 2. And as we said, I is equal to square root of negative 1. So we have just 2i. And x over here equals, or like it's just the exact same. The square root of 16 is 4 divided by 2 is 2. And negative, so it's negative 2, and that is an I. So, these are your values. Okay? So the x values we got is x equals 1 minus the square root of 5. X equals 1 plus the square root of 5. I'm hoping I got that right. Yes. X equals 2i and x equals negative 2i. Now these are our critical numbers, they're not our critical points. A lot of people refer to critical points as critical numbers, but they are not the same. They may get away with it when you're talking about it, but technically they're not the same. Critical number is a number, point is a point. So they're different just by their name alone, but anyway. So now comes the process of eliminating the numbers and finding out what's the actual points. So the function originally was, if I can find it, was x minus 1 on x squared plus 4. Now what we're going to do is we're going to sub in each one of these values into it. So the function 1 minus the square root of 5 equals 1 minus the square root of 5 minus 1 all over 1 minus the square root 5 squared plus 4, which equals approximately, roughly around 0.4, which is a tick, because it popped out a number, therefore it is real, it is defined in there, in the domain. So that's what we want, that's critical, that is a critical point. And here we have 1 plus square root of 5, and that equals, same as above, 1 plus square root of 5 minus 1 over 1 plus the square root of 5 squared plus 4, which equals approximately, doesn't equal exactly, it just sort of rounded up, 0.15, which is a tick because it is popped out a number, therefore it is in the domain. And now for this one, well, we have 2i, which means we sub in 2 multiplied by the square root of negative 1, and that's minus 1, and then we have 2 multiplied by the square root of negative 1 squared plus 4. Now hopefully you know this, but yeah, it's you can't square root a negative number. That's why they created imaginary numbers like I. which is actually a letter, but anyway. So that's why they created that, because you can't actually do that. So it does not exist, which means it's not a critical point. It's a critical number, but it's not a critical point. And for the negative 2i, I don't need to really write this out because it doesn't exist. Therefore, we can say that critical points are at x equals 1 minus the square root of 5 and x equals 1 plus the square root of 5 within the domain. Okay, so I hope you learned something from this video on critical points, and I hope you enjoyed it, and I hope you have a good day. Thanks for watching.